Hello, I'm Gil Carroll, Director of Business Development at AppliedFelts. For those that may not be familiar with us, we are the global leader in the manufacture of the highest quality felt and fiberglass reinforced CIPP liners used in today's gravity, sewer, pressure pipe, and potable water systems. We have been innovating since the invention of the CIPP process in the 1970s, with our tubes being on the very first CIPP projects installed in England over 50 years ago. A little background today. CIPP, which is the leading rehabilitation technology for gravity sewer pipelines, has always been challenged with concerns over the odor and potentially harmful emissions of styrene during installations. Styrene is a component of unsaturated polyester resin, the most cost-effective and commonly used resin system for CIPP and wastewater applications, with over 25 million feet of CIPP being installed annually within the United States. These styrene concerns primarily regard the contamination of waterways and job site odor complaints from the public. The solutions to these issues have been mainly limited to special requirements for on-site CIPP installations, such as filtering or controlled disposal of cure water when styrenated resins are used, requirements to utilize styrene-free resins such as vinyl esters and epoxies in environmentally sensitive areas, and improve public education or even notification on explaining these job site odors that may enter homes. In 2017, a study by Purdue University was published on worksite emissions during projects using CIPP, which raised concerns that chemical emissions can pose potential health hazards to exposed workers and the public. In rebuttal to these claims made in the study, NASTT commissioned another study of its own, which did mitigate some of these misleading claims, but also confirmed some legitimate concerns. This led to NASTT's update of worksite safety guidelines, which are still in place today. At AppliedFelts, we believe there was a more technical solution to the problem. From an industry standpoint, there appeared to be three technical options that could mitigate or negate entirely the rational concerns. The first option was to avoid using styrenated resins altogether. Although several resin manufacturers provide styrene-free resins for use in CIPP, the cost of these resins can be up to 50% more expensive than polyester resin systems, and curing can be relatively unpredictable and more complex to use than traditional polyester-based CIPP resin systems. Although this can be a limited solution, it was not really a complete one. The next option was the development of a filtration system that could be used to filter VOC emissions. This too appeared to be costly and limited solution given the size of the CIPP market and number of contractors who would need to access to the equipment and diligently monitor and manage the filters to use while performing CIPP installations. The third option was to identify means to contain the styrene and control its release to minimize concentrations in the air and the cure medium itself. Given that the CIPP tube is integral in the CIPP process and already used to contain the resin, a tube that could meet these objectives was one that AppliedFelts was committed to develop. So along with our development goals here, the project objectives were to construct a cost-effective tube that would not only carry the resin during installation, but that could provide a barrier containing the styrene to mitigate the potential for emissions while handling, installing, and curing our resin-impregnated tubes. Ultimately, AppliedFelts set up to develop a cost-effective product that not only provides the same quality and operational performance as our traditional TPU and TPO coatings used for styrenated resin installations, but also improves safe handling and use for workers, the public, and the environment. AppliedFelts' development team identified innovative materials and manufacturing methods to deliver a final product that would provide the desired styrene barrier we were in search of. After years of research, trials, and testing, those objectives have been met with Envirocure, a styrene barrier-coated felt or fiberglass reinforced liner. Independent testing has been underway. During a field trial conducted in late 2021, one of our contractors evaluating Envirocure for its barrier capabilities asked IUPUI to be on site with their styrene emissions testing equipment during a live install. It confirmed Envirocure's capability to contain the styrenated resin, with styrene concentration measurements never above the 20 parts per million threshold set by the EPA. The findings concluded that the use of Envirocure with or without a preliner during the CIPP installation process is a, quote, low risk level for exposure to styrene by workers and nearby public, unquote. Envirocure is also included in NASTT's Phase 3 CIPP emissions study, evaluating the breakthrough time of various coating and resin combinations, which is expected to conclude in early 2022. Perhaps the most revealing test was the smell test. Our sense of smell is far more accurate than gas gauges, and the overwhelming response from our testing has shown that styrene odors were either very faint or completely undetectable, even when walking up and putting your face right in the steam flue during curing. Going on to performance properties, our test results show that Envirocure is not only capable of maintaining the barrier properties all the way through wet out installation and cure, including the high temperatures associated with resin exotherm, it also possesses key characteristics such as being transparent for visibility during impregnation and toughness to resist damage to the barrier coating that can occur during handling and installing. And probably most importantly, the barrier coating continues to function under the stress from elongation and radial extension that occurs during installation, particularly in inversion installation. All requirements to deliver an improved product that performs at the highest level that the market has come to expect from AppliedFelts were met, including the delivery of a tube that will allow the CIPP process to continue to be a cost-effective solution. Envirocure is a polyester felt or glass reinforced felt liner with a multi-layer coating containing polyamide conforming to recognized industry standards ASTM F1216 and ASTM F1743. The tube is manufactured at AppliedFelts facility in Martinsville, Virginia, which is certified under the current ISO 9001 quality standard. Envirocure is manufactured in diameters from 6 to 120 inch for installation by inversion and 6 to 72 inch diameters using the pull-in-place installation method. It is compatible with polyester, vinyl ester, and epoxy resins and can be cured using hot water or steam. I should note that the CIPP styrene-associated exposure concerns have been somewhat mitigated by way of improved guidelines for ventilation and handling that have occurred out there in the marketplace and certainly have helped the issue. However, we knew we had to do our part through innovation in the containment of styrene within our CIPP tubes. Envirocure is AppliedFelts' response to the Trenchless market's needs for improving worker, public, and environmental safety, with the liner doing the heavy lifting in alleviating these concerns today and into the future. I'd like to thank you for your time today.